come to the second part of mathematics of chance. Now we are discussing about geometrical probability. That is, we talk about probability in the case of some figures. Okay, look at the first question. Calculate the probability of a dot put without looking to be within the green part. In your textbook, this shaded part is the green part. We have to find the probability of a dot being put in this green region. To find the probability of a dot being within the shaded region, we say probability is equal to area of the shaded square divided by the area of the given square. Okay. Now you know two formulas to find the area of a square. Area of a square is either side into side, which is represented as a square, or otherwise area of square is half d square. Area of the bigger square is equal to a square, isn't it? Let me write it. Area of outer square is equal to, we know side we took as a, therefore area is equal to side into side, which is equal to a square. Now let us talk about the area of the shaded square. Area of shaded square is equal to half d square. Is it clear, children? Now what is the diagonal of the inner square? I will show you. This is the diagonal of the inner square. From the figure, it is clear that diagonal of the inner square is same as the side of the outer square. So, area of the shaded square can be taken as half into a square. That is, replacing diagonal by side. Okay. Now what is the probability? Probability of a dot being within the shaded part is equal to area of the shaded square divided by area of the outer square. That is, you will get half a square divided by a square. A square cancels with a square. So the answer is 1 by 2. Second figure, a square with all vertices on the circle. You can see a square which is shaded with all its vertices on the circle. Here again we are going to find the probability of being a dot in the shaded region. Okay. Now I have drawn the diagonal of the square. You can understand this line is the diagonal of the square as well as the diameter of the circle. So I wrote it as 2r. Diameter of the circle is equal to 2 times the radius. Now let us write the area of the square and also area of circle. Okay, area of square. We know the formula. Area of square is either side into side, or otherwise we can use the formula half d square, that is half into diagonal square. So I am using the second formula, half d square, that is equal to, now diagonal of a square is nothing but the diameter of this circle. We know diameter is equal to 2r. So this d can be represented as 2r. So what do you get here? You get half into, instead of diagonal, I can write it as 2r the whole square. Is it clear, children? Next step, 2r the whole square gives you 4r square divided by this 2, which simplifies to 2r square. A 2 cancels with 4 and you get 2r square. Now you know area of circle. We know area of a circle is equal to pi r square. Now we are going to write the probability. So how do you write the probability? Probability is equal to area of square divided by area of circle. That is, area of square is 2r square and area of circle is pi r square. R square cancels with r square, so you get the probability to be equal to 2 divided by pi. Look at the third figure, children. Here you have a circle exactly fitting inside a square. Here again we are asked to find the probability of a dot being within the shaded portion. Okay, so what we have to find out here? Find the area of circle and also find the area of a square and divide area of circle by area of square. I took each side of the square to be equal to 2r. 2r is nothing but the diameter of the circle. Here, diameter of the circle becomes the side of the square. Now, let us use our formula. Area of square is equal to side into side. That is, what is the side? We took the side of square as 2r. So, you get 2r into 2r. That gives you 4r square. Now, let us find the area of the circle. So, area of circle is equal to pi r square. Now, we need to find the probability of the dot being within the shaded portion. So, to find the probability, we divide probability is equal to area of circle divided by area of square. That is, area of circle is pi r square, area of square is 4r square. Now, r square is the common term which can be cancelled. So, we get pi divided by 4. You know the value of pi is 3.14. Look at the fourth and fifth question, children. Here we are not going to use any formulas. From the figure itself, you can understand the idea very clearly. Here you are given a triangle got by joining alternate vertices of a regular hexagon. I have named the regular hexagon as A, B, C, D, E, F. And ACE is the equilateral triangle got by joining the regular hexagon. Now what I did was, I took the center point and joined it to A, E and C. Now from the figure, it is very clear that area of this shaded part and area of this unshaded part are of equal area. Similarly, this shaded part and unshaded part are of equal area, and this shaded part and unshaded part are of equal area. So, probability of a dot being put within the shaded portion will be equal to 1 by 2. Similarly, in this figure, a regular hexagon formed by two overlapping equilateral triangles. What I did here is, the center point is joined to all the 6 vertices of this hexagon. From the figure, it is clear that area of unshaded triangle and shaded triangle have same area. This unshaded and shaded have same area. In a similar way, if you look at all the 6 triangles, inside and outside, you can understand probability of a dot being within the shaded part to be equal to 1 divided by 2. So, the first figure, you can see 6 equal triangles. So, the probability of a dot being within the shaded portion is equal to shaded triangles are 3. So you get 3 out of total number of triangles is 6. So the answer 1 divided by 2. And in this case, you can see 12 triangles totally and 6 triangles are shaded. So we get the probability of a dot being put in the shaded region is equal to 6 by 12, which also simplifies to 1 divided by 2. The next exercise we will discuss in our next class. Thank you.